Hey, I'm Patrick, the physics teacher, and today we're looking at pendulum physics. As we remember from class, the period of a pendulum is described by t equals 2 pi square root of L over the acceleration of gravity. A way to remember this formula is by doing unit analysis. We remember that the period must be in seconds. And in order to get seconds, we have our 2 pi, which is unitless, and the square root of a meter divided by a meter per second squared. And in the square root, a meter divided by a meter second squared is just a meter times a second squared all over a meter. And the meters will cancel, and we end up with a second squared under the radical, which will give us units of a second. The materials needed for the pendulum lab are a ruler, tape, string, scissors to cut the string, a pendulum bob, and a timer. So now that we've set up our pendulum, it's time to take some measurements. The first thing to measure is the length of the pendulum. This goes from the pivot point to the center of mass of our bob. So the center of mass is here. It's measuring about 20 inches. Remember that we also don't need to take the weight of this bob because the period of a pendulum is not dependent on mass. We're now going to measure the period of our pendulum. To do this, we're going to raise it to some amplitude, let go, start our timer, and stop it. For 5 period swings, our stopwatch measured 7.85 seconds. Now if we divide this by the number of trials, which would be 5 periods, we end up with 7.85 seconds divided by 5 equaling 1.57 seconds. For our theoretical value, we calculated the length to be 20 inches. Because the rest of the world runs on the metric system, we need to convert this over to meters. To do this, we're going to use the train track method. First, we will convert inches to centimeters by multiplying every inch by 2.54 centimeters per inch. Next, we need to get this over into meters. In order to do this, we know there are 100 centimeters in a meter, so we have a meter and 100 centimeters per meter. Now, if we look, our units are canceling out, and we end up with meters. The final value for this would be 20 times 2, that gives us 40. Half of 20 is 10, and this is just going to give us about 50. Now if we divide 50 by 100, we end up with 0.50 meters. We also know that the acceleration of gravity is 9.8 meters per second squared. Plugging this into our period formula, we should get t equals 2 pi square root of L over G, being 2 pi square root 0.50 meters divided by 9.8 meters per second squared. If we check our units, we're going to end up with seconds coming out, and period will equal 1.42 seconds. We can see that our theoretical measurement was quite close to our actual measurement. If we had been a little more precise and maybe taken many more measurements over time, we possibly could have ended up with a theoretical value.